So let's. Okay. Is it? Do we need to record this meeting? It's just an informal discussion. Anyway. Okay, they're 21 now. So, Sagar, the document where they all filled their topics and their team members, that's completed, right? So
Yes,
I'm
Chitra,
just
it's completed.
okay. I'm just referring to that. You know. Okay, so I am not personally aware of the status of the project aspect. I do know that all of you have gone through day two, day three, hopefully, whatever Vikrant's videos are there, as well as cleared any doubts by now. And I also hope you enjoyed yesterday's talk with Riza ma'am. And um, well, we apologize for the technical issues and whoever was playing the mischief yesterday. We're very sorry about that. I don't know how that happened, but that will not happen. So that will not happen again. And if it was one of you, and if you want to talk about it, you can always DM me. And I don't know why someone from this team would do that. So anyway, it's been a surprise for us. So coming to the project topics, I just wanted to just understand what all of you are working on. Have you started anything, and whether you're stuck somewhere? And lastly, how much can we help you in this progress? Because I can do some amount of support I can give in terms of connecting you with a suitable mentor if required. But you have to reach out and you have to talk about what you're working on in detail so that we can help you with it. Okay. So please feel free to just open up, talk about any progress, any obstacles so far, and also try to be a little bit more specific about what you plan to work on. I can see the topic already, so I'm expecting a little bit more specificity. Okay, maybe we can start team wise. Sustainable development in mechanical engineering. Tanmay Bhagat and Sankarshan and Malaika. Are you all here? Team one.
Yes, I'm here actually.
Okay, hi. This is Tanmay, is it? Okay. Would you like to quickly update all of us? What is
Yeah,
the prog?
so talks from sustainable development in mechanical engineering, but since we had a group member from physics related stuff, we just tried to find a common topic for us, and so we came to like hydroponics, the power to grow food. That is our topic right now. We have been reviewing some papers on like on Google or Google Scholar. So that process is going on right now. Hello.
Okay, I can see that it's a huge scope for this topic. It's a very interesting topic. But according to me, it's a huge scope. I don't know if you have something more particular in mind.
Yeah. It is like so we have just started to get some inputs from the papers, but yeah, we will like scope down to some a common a smaller topic where we can work on it.
Okay, so please do that. And if you want to have a personal discussion, just me and the three of you, then let's do that. Maybe I can just help you brainstorm and pick something. I can't help you like in with the depth of the project perhaps, but maybe I can help you to brainstorm. So if you would just like to connect and have like
Yeah,
an
sure, sure.
conversation, we can do that. Okay.
Yeah, sure, sure. I'll try to schedule a meeting with even other two members.
Okay, so Monday
A
onwards, I'm
discussion.
available for the whole week. So what I'm going to do is I'm going to send you
Okay.
guys a link. You can schedule a
Yeah.
meeting whenever you want. Okay, cool.
Okay. That's fine.
Okay. All
Yes.
right. Very,
Yeah.
very interesting topic. And I think I have some interesting inputs as well. Um, yeah, let's talk about it then with the team. Okay, next is Team 2, Astrophysics, Stellar Evolution. It also says Magnetars. I think this is Prerna's team. Is anyone there from Prerna's team?
Excuse me. I have to leave the meeting because our festival is going on right now, so I cannot stay long for long.
No, no problem. No problem. Please carry on.
Yeah. Thank you.
Hi. Is Prerna here or anybody from that team? Shubhashri and Mirya.
Yeah, Shubhashri is here.
Hi. Yeah, Shubhashri,
Mirya,
would you like to talk a little bit about your progress this week? Personally, what progress you've had, but also with the project?
I am looking at some research papers and about magnetars.
Okay.
Prerana is not here, I think.
Okay, that's okay. Did you have, Tanmay also, I think he left the call, but the first two teams, did you have time to meet informally, to meet with just your team members and have a discussion so far?
No, not yet.
Okay, okay. So that has to start, okay? So that has to start
Okay.
this week, preferably tomorrow itself. So Shubhashri, can you take the initiative for your team and make sure that you have one proper conversation with Prerna and Mirya? Just about,
Okay.
try to talk to them about, hey, what are magnetars first of all, and then what is the scope of this report that we can write? Do you want to do a calculation of or evaluation of some sort of the magnetic field, or what do you want to do, right? So just to have a brainstorming session with them, okay?
Yeah, okay.
Cool. So Shubhashri, I will get check with you personally on Monday to see, okay, whether you've had a meeting. All right. Linguistics. So we have Anushka and okay. I thought more people were working on this. Team 3, Anushka, are you here?
Yes, hello, ma'am.
Yeah, hi Anushka. I thought you were working on working with someone else, right?
Yes, ma'am. Actually,
Is-
we of three buddies were going to work on this linguistics, but they have decided some other topics. So now I'm working with Astha on artificial intelligence and natural language processing, in which I'm going to collaborate linguistic and artificial intelligence.
Wow. Okay. Very interesting. You're working with Asta.
Yes, ma'am.
Okay. Perfect. Perfect
Hello,
team.
ma'am.
Hi. So hope you had. Did you have a chance to talk to each other this week?
Yes,
Yes,
ma'am.
we do.
Okay, wonderful. Any progress you want to share with all of us today? And what have you discussed? What is the idea behind it?
Actually, we are trying to divide the into artificial future of artificial intelligence, and
Okay.
in case of natural language processing, we are trying to focus on that. Can we use some native languages of India, for example, Sanskrit, in natural language processing? As till now, we have dealt with English, French, and other languages only. So instead of that, can we find some other languages for beneficial of NLP? So
Wonderful. Um, Anushka, you're a graduate student, right? You're a grad student.
I'm in TYBSc mathematics.
I'm sorry, I don't know. Are you doing your masters or bachelor's? I didn't quite get that.
Third year BSc mathematics.
Oh, third year BSc. Okay, okay. So I feel this is a really wonderful topic, and I can actually get you some help. I can get you some mentor who can actually help you with this. So think about it deeply, and maybe this is a one such project that we can actually continue even after this course is done. So if you want to extend the project under Nakshatra for maybe a span of 2 months at least, it's a very, very valuable idea that that you could work on. And it's interesting that you want to work on Sanskrit. I do think there is some level of organization in Sanskrit which might help what you're talking about. And but there has not been much work done before, so it's a very, it's very interesting. So
Yes.
I'll again this week let's talk about it. The three of us, let's get on a meeting and talk about it. And I will introduce you to someone maybe who can help us out better. Okay.
Yes, ma'am.
Okay,
And
ma'am,
at that
thank
time,
you.
I will share some things which I have tried to read about.
Wonderful. Yeah, please do that. Especially, I think with NLP, there has been some papers already regarding Sanskrit. So please try to find if there are any such articles or papers and show it to me when we meet. Okay.
Yes,
You,
ma'am.
you
Sure.
may or may not. Yeah, it may not be very easily accessible. You might have to dig out on the internet. So just try to find. There are some people who worked on.
Yes, ma'am.
Okay. Wonderful and very exciting topic. Cool. Next team, team four, set theory, Gaurav and Sanket. Are you guys here?
Hi,
Hi.
hello.
Yes, ma'am.
Yeah. Any updates?
Actually, we're still discussing about the topics related to set theory, which we are going to include in our research paper.
Okay.
Up to this point, we are decided some topic to include, such as Russell paradox and its different solutions, and Cantor's theorem, etc. And right now, we are still finding some research paper which explain different solution for Russell paradox, which are interesting. So
Also, Cantor's set will be our main focus, and there are many topics also that some topics don't have a proof also, and like there it does not exist any set which has a cardinality more than alif node and less than continuum. So these are unproved. We don't have proof of these topics, so we will try to discuss. We will try to write about this and reading about this.
Okay, I hope you got to interact with Raisa ma'am yesterday. I am definitely not the right person to talk about mathematics. Maybe Vikrant can help a little bit. But I just want to understand if you are trying to do like a conceptual study of, what is unsolved, or do you plan on doing or showing some calculations of your own? I just want to understand that.
We will just try
Okay.
to know the things which are unsolved. Not we are not going to give our own calculations.
Got it. Got that. So I think that's a very good idea. So maybe Vikrant can help, but I'll also maybe keep in touch with Raisa ma'am. I can give you the email ID, yesterday's speaker, and you can directly talk to her, right? So she might have be able to help you. And also just use the Telegram discussion forum. I'm not talking about your later group. I'm talking about the discussion group. If you're not part of it, maybe Saga can send a link. So try to use that also. There might be some people there who can always help you. Okay.
Okay,
And yeah, if you need any personal mentorship, you just let me know so that I can connect you with someone ideal or Matt. Okay.
Okay.
Cool. Yeah, but please do have a meeting with, internally with you and your teammate. Just make sure at least, every day, some 30 minutes, if you're able to meet, that would be wonderful so that there is some progress. Cool. Sashwat, are you here?
Yes, ma'am, I'm here.
Yeah. Hi, Sashwat. So any updates?
Uh, uh, I've been working on virtual reality. And lately, it's not much of a progress, but still I'm working.
Okay. Sashwat, I think you don't have a PC, right? So I hope
Yeah,
you're
no,
looking.
I have already bought one, so I'm actually figuring out it. So,
Oh, okay. Wonderful. Just DM me if you have, just tell me about your progress. If you have any issues, you just tell me, okay? I hope
there
you're
is
able
no,
to go through. Uh-huh.
There is no issue.
Okay. Okay.
It's
You are
it's going
enrolled on
on.
the LMS, yes? You've
Yeah,
been
yeah,
enrolled
yeah,
on the LMS. Okay, fine.
yeah.
All right. Thank you. Go ahead and I think you can do a good conceptual study of virtual reality. So
Yeah, I'm
yeah,
actually just
cool.
surfing over all the internet, just trying to find whatever. That's it.
Sure. Maybe you can talk about how it works, right? Just the general aspect of it, or maybe you're interested in the experience of it. So,
The
what it does to
experience.
the brain or the psychology, that also is something you can explore.
Yeah, yeah. There are a really lot of things. Something
Right.
it
Go
even
ahead.
causes sickness and the virtual reality sickness. That's the new topic I actually came across right now.
Okay. Yeah, that'll be very interesting. So looking forward to that. Just start making sure you're making, keeping notes of whatever you read.
Yeah, yeah,
Otherwise,
yeah,
it
yeah,
will fly.
yeah.
Okay.
Yeah.
Yeah, that's a general rule of thumb,
Thank
guys.
you.
If you're all, thank you. Yeah. If all of you have started reading up and stuff, just maintain your personal notes or have a collaborative document for you and your team partners. Make sure everything is documented. Okay. Is anybody there from Anjali's team? Sahiti? Anyone? Okay. Um, Anandu and Hariharan, right? The physics and chemistry of chlorophyll. Anyone?
Hello.
Hi.
Yeah. So we were basically learning the basics of latex, and also we are trying to explore the chemistry aspect of it too, reactions and structure, how to do it in latex, and we had a discussion between us on this topic 2 times. I mean, in this week, and yeah, it was good. Then we are on this topic updates as the topic it is. We are basically exploring the the chlorophyll, particularly observing as there is the many pigments, chlorophyll A, B, C, and all that. So white is observing particularly blue violet wavelength, and B is observing red blue wavelength, and the reason for it, and connecting it with the HR diagram and all that. So yeah.
Wow, that is fascinating. I was already mind blown by your topic idea. So keep it going. Very, very excited to see your final presentation. So I think you're connecting like even the physics of like sunlight and things like that, right? If I
Yes.
understand correctly. Okay,
Yeah.
wonderful. Maybe you can obviously connect it to some level of biology as well. So very interdisciplinary topic.
Yeah.
Cool. So you're going to write like a report about how it works and I guess explaining the basics of it, right?
Yes.
Are you exploring the role it plays in photosynthesis or something, or are you just talking about the color, pigmentation, and things like that?
Basically, it is an exploration towards infinity, but yeah, we'll try seeing.
Okay. All right, man. All the best.
And also, we like
Mhm.
to continue it further after this course too, if it is possible.
Absolutely. Can I connect you with someone who she has a master's in neuroscience, but she's obviously from the biology background.
Okay.
So it might be really helpful to just have a discussion with her. She's from TIFR. So maybe I'll just schedule a meeting for this week with her, and you both can have a discussion. Is that okay?
Yeah. Yeah.
Cool.
Thanks. Actually.
Okay, because I would like to hear about it further as well.
Okay.
Okay, let's
Thank you.
do that. And Wednesday there is a session with a biologist, so make sure you don't miss that. There is a official discussion. So the speaker is a biologist. So make sure you join that.
Yes. Yes. Sure.
Okay, guys, thank you and good luck. Whoever just spoke, you were Hariharan, is it? I'm sorry, I don't know who spoke.
Anandu.
Anandu, okay, cool. Theoretical astrophysics, dark matter. Okay, Julie or Srinidhi or
Hi.
Nagashri. Anybody here? Hi.
Hi, it's Julie.
Hi, Julie.
Yeah.
What's
So
up?
far,
How's
we were actually kind of going back and forth between inflation theory and dark matter. So we've just finalized on dark matter, but we still have to read a bit further so we can narrow it down to something a bit more interesting or more specific. So that's all the progress that I have at the moment.
Okay, this is something that Sagar and I can definitely brainstorm with you.
Mm.
So, yeah, so make sure you just schedule a meeting as well, because if you already decided to work on dark matter, it's still a huge, wide
Yeah,
net, right?
yeah.
I mean, it's absolutely you could be talking about anything from the basic proof of dark matter all the way to the beginning of the universe. So
Mm.
you really need to finalize something quickly so that you're
Yeah.
able to find the right articles and papers to read.
Yeah.
Otherwise, you have thousands of papers and you
Mm.
won't know what to read, right?
Yeah.
So I would recommend you finalize the problem statement by Monday. Can you do that?
Okay. Yeah.
You're casting a very wide net. Since you already thought of inflation, maybe you can look at that aspect. Does dark
Mm.
matter play a role? Perhaps in the CMB, right? What are the
Yeah.
footprints? Something like that, where you're able to connect the two domains.
Okay.
But whatever it is, please try to confirm by Monday, and I'll have a chat with you then.
Sure.
Okay,
Thank
awesome.
you.
Yeah, sure. Julie, you're doing BSc, right?
No, I actually finished my MSc.
Oh, okay, cool. So
Yeah.
I'll definitely let's have a conversation, and I should be able to connect you with. I think there's a couple of PhD fellows working on dark matter, so
Mm.
maybe I'll just connect you with them as if you're
All right.
interested.
Yeah.
Okay,
Thank you.
all right. Thank you. Okay, we have some really exciting topics. Uh, let's see what all of these come down to. Computer science. Okay, I think that's already done. Astrophysics, planetary science, exoplanets. Anybody from that team? Anirudh, Akash, and Kunal.
Yes, yes, ma'am. Anirudh.
Yeah, hi.
Hi. Actually, Kunal and Akash are also here.
Okay.
So maybe they can unmute and just introduce this.
Yeah, but Anirudh, can you just give me personal update of how it was for you this week, and whether you had a chance to talk to your teammates about the topic?
Yeah. Yes, actually, on the day which we created the team, that day we created a Telegram group for ourselves, and we discussed about our topic. We had two Discord calls, and we near finalized our topic, which is an optimum way to detect exoplanets. Essentially, we'll be studying various methods to detect exoplanets with respect to the light curve analysis method, and we will be preparing our report and our opinions on different methods of detecting exoplanets. So,
Okay,
starting
wonderful.
on,
Mm-hmm.
basically, we have prepared a Google Sheets, and I mean Google, so where we can put links and videos that we all three of us have come across, and we will go through that literature. So on Sunday we are meeting once again for
Oh,
discussing that. What?
yeah. Hey, this, you could even call it a comparative study, perhaps, because you can simply say what is the efficiency of each technique, right? Each technique is
Yeah,
fundamentally different.
Yeah,
that's
that is
what
what
we
we're
were going
planning on
for.
doing.
Okay, that's a
Yeah,
really cool idea. Yeah.
it's basically a comparative study only, as they said.
Okay, wonderful, wonderful. Yeah, maybe make sure I add some numbers, add some, what is the efficiency of the techniques, some amount
Yeah,
of data as to how many exoplanets have been detected so far and things like that. So you
yeah,
should
and
be
we'll
able to
be
predict.
other research papers as well in that area.
Okay. Yeah, sorry, I didn't get that. What did you say?
After that, we'll be referring to other research papers as well in that area. So it should be like a review come comparative paper.
Perfect. Yeah, yeah. So you can refer papers that address each of the techniques specifically, right? So
Yes.
You can read the light curve technique kind of paper, take some data from it, then go to the next technique. So,
Yeah.
okay.
Kunal and Akash, do you guys want to add anything? If not, then
No, that's about it. That's our topic.
Okay.
okay. Thank you.
Thank you.
All right. That was great. Okay, quickly moving on. Sankalp and Abhishek Joshi, what's up and how has it been so far?
Yeah, Sankalp here.
Hi.
Yeah, this week me and Abhishek had a talk about particle physics, but we decided to go to do something in quantum physics because since he's in my MSc and I just passed the second year, so I was not having an idea about quantum mechanics, but he told we will dive into the basics and then later we can work on it.
So you've decided that the topic will be in quantum mechanics, is it?
Yeah, something in quantum mechanics.
Oh, okay. Is Abhishek is not here? Abhishek.
No, I guess he's not here because he told me he's having time after 8 or 9 at night. So we usually talk at night only.
All right, you know what? Just convey to him that if he wants to work on something a little bit more complicated, he's free to do so. And you can always work on the introductory aspects of that topic, which you can add to the first 2 pages of the report, right? So you
Yeah.
could give an introduction or a conceptual overview, and he can work on something more challenging if he personally wants to do that. So just convey that to him.
Okay.
Because the collaboration doesn't mean that you have to bring down the level or whatever. You can always add different levels of challenge to the same paper. Okay. So yeah, just let him know.
Yeah, I mean, even complex theories I can manage. But he also told me that even the mathematics of quantum physics you don't have in second year or third year.
Yeah.
So yeah, we can discuss over that also.
Okay, cool. All right. Yeah, if you need any help, Sankalp, just get back. I think Vikrant is someone who can really help you with Vikrant and Sagar. So if you just need some help, do that. And also there is so Nakshatra has something called tribes. Like these are free, you can think of them as college clubs, right? How you have clubs. So these are tribes which focus on one particular subject and they kind of tackle some new concept every month or new goal or objective. There is going to be a quantum mechanics tribe starting soon. So just try to join that because perhaps it will help you, to join a study group and you can work on your math part of it.
So that tribes are in Discord server or?
Yeah, they'll be starting on the Discord server this week onward. Okay, so they're free for anyone to join. So just be a part of that. They'll be like focus study circles, so you can just join.
Yeah, sure.
Cool. Okay, finally we have 2 more teams. I think Adept Spiderware. What? Spider Weave and other previous materials used. Okay, I have no clue what this is about. Do you want to update me on this?
Good evening. Can you hear me?
Hi. Good, yes, good evening. I'm sorry your topic is not too familiar to me. Do you want to explain it a little bit to all of us?
Yes, sure. Because I came to this topic like 2 weeks before I joined your this course. So I was myself interested in it. So I thought I'll write an article on it. So basically, there are CubeSats which we send to the moon or the Venus or Mars. CubeSats are satellites in shape of cubes. So earlier, this was done through rigid aeroshells, and they were made of different panels of materials, and they would put them together. But what was seen was the temperature would rise and they were inefficient in terms of volume and mass, and it was not good. So recently a team developed a material, not recently, I think 2015, and like recently it came out, the article from NASA, that they took a carbon 3D structure with ribs and struts, and like it could be deployed, and it was like flexible, and it was one single panel of material. So this reduced the temperature and the pressure, and also it helped in volumetric constraints when ejecting it. So I felt like this was a very good topic to go on, but what I want is I don't want to do a review article. Like there are only like 3-4 articles, as this is new, 3-4 articles are there from which I can do, but I don't want to do a review article. I want to see like how this works in different planets according to their atmospheres, like something computational. But for that, like I discussed this even with Vikrant, and he said to go by heat signals. But again, if you need heat signals, you need some inputs, which I'm trying to find out. So recently I came across this, like one day before, I came across this paper where they specially discussed this case on Venus and how it behaves in the atmosphere of Venus. And there are a lot of new terms there for me, like gamma, and also gamma, not in the sense of decay, but something else, and ballistic coefficient. So I'm trying to learn those new terms, and then like at least try to see what happens in different atmospheres of other planets. So that was my idea, but I think it will take time since I'm new to this.
Okay, want to start by writing a 2-page explanation of the idea that anybody can go through and kind of immediately get or understand, and then that could be your submission at the end of 1 week. But you can maybe continue the project under us. Would you be interested? Because it seems like something you would want to do for slightly longer time.
Yes, like see different planets and then like plot it out nicely. Stuff.
Okay, if you're looking at that, I can introduce you to some people who have worked on maybe planetary physics and things like that. Maybe you can start from there, because I don't have a clear idea of what exactly it is. I'm pretty new to this idea. So can you start by, basically we expect everyone to submit at least a 2 to 3 page document at the end of the LaTeX program.
So I have some articles, like introductory articles. So I'll read that and like create an explanation of like an abstract sort of thing of 2 pages of what I plan to do.
Exactly. Just an overview of what you plan to do, or what the idea is. So from there, we'll take it forward, and you can extend it perhaps to a month, so that you can work on it a little bit more in depth. It sounds very interesting. I think Jishnu would be actually a good person to have a informal chat with. He's done a fair amount of, I think, mostly stellar physics, but also planetary physics.
Sorry, I didn't get the name. Could you repeat it?
Jishnu P. Das. I'll introduce you to him. I'll be sending a link on the group. Just schedule a meeting for the coming week. Okay.
Okay.
I'll bring Jishnu on the call, and we can have a talk.
Thank you.
Okay. All right. Very interesting idea. All the best. All right. We have one last person. Ansi, are you here?
Yes, ma'am. Good evening.
Good evening. Again, probably not too familiar to me, your topic. Would you want to give us a quick overview?
I'm working on CQDs, carbon quantum dots. It's a new emerging topic in nanochemistry and fluorochemistry. Actually, I want to talk about the synthesis, the early method of synthesis and the modern synthesis methods. And I'm trying to induce new methods of synthesis, which is practically, it's basically a theory. I'm trying to talk about the biomass-based CDs and organic way of synthesizing CQDs, and of course the applications of it.
Amazing. What is the full form of CQDs again? I didn't get you.
Carbon quantum dots.
Okay. Is this something you're working on as part of like your graduate program or something already, or is this something you thought of for this particular course?
Actually, I did a paper during my bachelor's in fluorescent chemistry. I thought of extending the topic to quantum dots.
Okay, wonderful. I'm not sure if I can entirely like connect you with someone who has a specific expertise on this. But if you can tell me what subject you require a mentor to be, perhaps I can connect you. Do you need
Uh,
someone experienced in chemistry or quantum mechanics or physical
Actually,
chemistry?
actually, someone from nanochemistry or quantum chemistry.
Nanochemistry. Okay. Okay. Cool. I think nanochemistry is doable. I'll just try to help you out. But please do work on it this week. Just go ahead and work on it, and perhaps produce an overview paper similar to what I was telling before, like a 2-page document to begin with. And
Yes.
if you would like, you can continue for a month, since the topic seems pretty intense and you might have to put in more work hours. So work on it in your own pace, and then we can take it forward. So
Yeah, sure.
we'll support you from our side as much as possible. I think there are some professors, including the guide, who's guiding another project right now. I think she's also quite familiar. So we'll try to connect you with the prof directly if that helps.
Okay.
Okay.
Thank
Cool. Thanks a lot. I think with that, we are done with everybody's update. I have to scoot now, but Vikrant is going to take over for just 5 minutes more. It's about just survey, how you should maintain some documentation, just making sure that you're taking a disciplined and organized approach to whatever you're doing so far. So thank you guys. It's absolutely refreshing to listen to all of your different ideas. Very glad it's interdisciplinary. So I want to work with all of you more on a personal note and get to know all of you better. So looking forward to the one-on-one team meetings this week. Okay.
Hello, Sitara. Hello.
Yeah, tell me, Sagar.
Yeah, and today at 9 o'clock we'll be having the campfire discussion also by Asta and team about AI.
Okay, cool. Yeah, that can go on. Yeah, I'll try to join at 9. Is Vikrant here? Can you take it forward?
Yeah, I'm here. Can you hear me?
Yeah. Carry on.
Right. So I'll try not to take a lot of time, maybe max 10 minutes. And you guys have made my job much easier because all of you have, in a way, started your projects. You've started reading about stuff and all of that. So all that I want to point out right now is how do you go about reading stuff, right? I mean, where do you start off with? And what is allowed as a reference in your documents, in your reports, and what is not allowed, right? So I'll just quickly tell you about that so that there's no much confusion for this or for your future projects that you will be doing as your bachelor's projects or your master's projects or any of the other types, right? So the best place, of course, to start reading about anything that you want to learn is Wikipedia, no doubt, right? But then Wikipedia is what we call a tertiary source of information, right? But I won't get into the technicalities of it. But it's sort of a compilation of knowledge from several people and not the original authors of, or not the original founders of whatever it is that you're studying about. And of course, this naturally doesn't apply to everything, but it gives you a rough idea of what I'm trying to say here. So coming back to the point, you can start off with reading Wikipedia and it gives you a pretty good idea about what the whole topic is all about, right? Like for example, if I'm reading Special Theory of Relativity, I'm gonna, you know what, I'll just share my screen perhaps and we can have a discussion based on that, right? Share screen. Oh wait, I haven't even opened Special Theory. Can you guys excuse me for one moment? I think there's someone home. Sagar, can you just take over for a minute?
Yeah, Vikrant. Yeah.
Please continue. I'll be back.
So Vikrant was talking about Google, Wikipedia. There's like a basic way of getting papers. So if you go to Google Scholar, you'll be getting both published and unpublished research, isn't it? So published will be like there are so many journals. Like if you are in astrophysics, there are the Astrophysics Journal and the Physics Newsletter. So These are some common journals. So, and also one way of getting research paper is like, if you know the detail of the research paper, you'll be getting it to Sci-Hub. Sci-Hub is not like not a legal place, but still it's a
let's
good.
not, let's not get into that right away, right? I mean, we'll come to that, right? We'll come to that. Okay. Sorry for interrupting though, but yeah, I mean, Sci-Hub and all is far away. We'll come to that when the time comes. But anyway, like I was saying, I'm gonna quickly share my screen and tell you about a basic way that you can go about finding papers to read for your particular topics. Right? I'm gonna share a particular window. No, I'll share my entire screen. Right? It doesn't really matter. Can one of you confirm if you can see my screen? All right, Asta says yes. All right, thank you. Right, so if you can see my screen, this is the Wikipedia page for special relativity, right? So now let's say I'm quite interested in special relativity, right? I want to work on a project related to SR. So the very first thing I do is I Google special relativity, and the first page that naturally comes up is a Wikipedia page. Now you can go about reading this entire thing, right? There's a lot of text here. There's these Galilean transformations and so on and so forth, Lorentz invariants, and you see a set of equations. There's these transformation drawings, blah, 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 blah. And, you know, this itself gives you a very good idea about what special relativity is all about, right? But then this is a culmination or a compilation of knowledge that has been added by hundreds, if not thousands of people from all around the world, right? And each of them has their own understanding of a particular topic, right? You know, that's exactly what physics is all about. Like in this case, physics is all about your point of reference. It changes with every person's interpretation, right? Every frame of reference in this case. But then what stays constant is if you scroll all the way down here, you find your primary sources, references, and in some pages you'll also find bibliography, right? Now, this is the most important part that sort of remains same no matter who you are, right? I mean, if you are referring to special relativity, then you will refer to Einstein's original paper on special relativity, which is on the electrodynamics of moving bodies, right? That's a translated version, but that is the first thing you would ever refer to because that's where SR was born, right? That's the very first paper on SR, and that's the first thing you would refer to. So if you are writing an article on special relativity, you would not quote Wikipedia, but you would rather quote Einstein's paper directly, right? And that's what we mean when we say Wikipedia is not to be taken as a source of information or a reference directly, because it's a compilation of knowledge from different people, right? But the background for all of that is Einstein's paper. So what you're supposed to cite in your paper is Einstein's paper, right? And the same applies to the rest, right? There's papers by Lorentz, and there's Benford, there's Peter Zeeman, and if you're writing a paper on Zeeman effect, then you would refer to a paper. I mean, you'd cite a paper by Zeeman himself, right? Wherever he first introduced his idea of Zeeman effect, it wouldn't have been called Zeeman effect, right? You don't call something after your name by yourself, right? Someone else calls it that, and so on. Then the next kind of things that you see are textbooks, standardized textbooks, right? So Griffith's Electrodynamics and Relativity, Jackson's STR, Goldstein's Classical Mechanics, Langsau's Cornelius's Variational Principle of Mechanics, and so on. These are all textbooks. Now, these also can be accepted as valid sources of information because these are standardized textbooks used all over the world, right? Now, you can also find several textbooks that are local, right? Now, there are many authors, many Indian authors, for example, who have written several books on classical mechanics, on relativity, and so on. But when you look at Wikipedia pages, you find the standard textbooks, right? Or if you were to look at the syllabus pages of any college or any university, you will find these standard textbooks like Griffiths, Goldstein for quantum mechanics and classical mechanics. You might also find Resnick for special relativity, and Marielle Bose for mathematical physics, or Arfken and Weber for mathematical physics, and so on, right? you have these fixed textbooks. It's very similar to how you have H.C. Verma for class 12, right? How you have H.C. Verma volume 1, volume 2 for your class 11 and 12 that you use to prepare for your competitive exams. Similarly, all around the world, there are a few accepted standardized textbooks. It's not that the others are wrong. It's just that many people prefer to use this over others, right? Just so that there's a sense of continuity if between a student in India, a student in Germany, a student in the United Kingdom, and a student in the United States, right? All of these people, if they are referring to the same Griffiths electrodynamics, then you are ensured that everything that you are talking about is going to be in the same level, right? Because all of you have referred to the very same textbook, probably even the same edition. It doesn't really matter, right? So these again can be used as proper sources of information, and these again can be used as a proper reference or a proper citation in your particular reports or anything. Now you see here, he says Griffiths, David J. 2013, Electrodynamics and Relativity is the name of the chapter. And the name of the book is Introduction to Electrodynamics. This particular edition that this Wikipedia page uses is the 4th edition. And the reason edition is also important is because with every edition, there's always some changes here and there, right? So your 10th equation of the 11th chapter might not be the same in every edition. There's always those minute changes that happen here and there. And that's why it's always a good idea to also mention the edition of the textbook that you're using, right? And ISBN is just to make sure that you're using a authorized version and not some copied stuff and so on, right? So that's a very small brief about all of that. Let's see what else. I hope this does give you a good idea about what you can do. And again, right, when you if you want to read research papers, if you don't know, like if you're not satisfied with the knowledge given by Wikipedia, I'll just quit this. If you're not satisfied by the knowledge given by Wikipedia, then you always have these research papers available in the primary sources or anything. So let me just pick up another topic. So I like general relativity, but again, we've just done special, so I'll skip that. I'll probably pick something in set theory, right? I'll probably talk about Lie groups, if you're familiar with it. I'll Google Lie groups, and like I said, the very first link that you see is usually Wikipedia, so I'm just going to click on that. Right now, there's a lot of mathematics here, abstract algebra and stuff, but I will scroll all the way down, right? Assuming I've read the entire thing and I'm not still satisfied with it. There are a few citations here, which means these are textbooks and papers from where it's been taken. Now, most of these you can see are taken from a book by Hall, right? And there are particular theorems that have been taken and so on and so forth. But there are also references, right? There are textbooks here. There are a few papers here. You see this emergence of theory of Lie groups. That might be a paper or a textbook, I don't know, right? And so on and so forth, right? And this review by Lie groups, a review of Lie groups and so on. These again can be used by you. So you would directly read them by yourself and put your interpretation of these papers in your report. And you would cite those papers, right? So if I'm picking something from this particular thing, it says in Japanese, but okay, Lie groups and Lie algebra 1 by Kobayashi and Oshima. If I'm picking something from there and I'm putting my own interpretation of that particular thing, I will be citing Kobayashi and Oshima's work, right? Because that's my primary source of information, right? Do not by any chances quote any sci-fi articles, the articles that you read on phys.org or Scientific American or what are those other websites, Science Daily or those random websites. Do not quote them. Right? Those are just pop science articles written for the general public to understand what's going on in the world of science, but those are not citable sources of information. What you can cite instead is at the end of these articles, they would have referenced or they would have given the links to the original work done from where they've written this particular article. Those, yes, you can refer. The website itself, like phys.org, no. And you can also not put YouTube videos, any lectures that you watched or any stuff like that. That also is not an acceptable source of information because those are sort of those lectures that you get in a class, right? Now, when you're writing your report or when you're doing a project, wherever you're doing it, you don't specifically mention saying, this particular teacher taught me this thing in this particular class and in this semester and in this year. That doesn't make sense, right? So lectures from YouTube or YouTube videos of any sort are not allowed as references or citations, right? You can watch those lectures for your own understanding, but do not cite them in your paper. Once you've watched it for your understanding, try reading a very closely related paper to it and see if you understand that. And that paper can be put as a reference in your document. All right. Now, I've been yapping around for quite a lot of time. So I'll open this platform up for questions. If you guys have any questions, go ahead. I don't know if you understood half of the things that I said.
So we can never like cite Wikipedia itself.
No, yeah. So in your reference section or in your bibliography, never put a Wikipedia link. Okay.
So like I have a doubt. I like before I read something on Wikipedia, how do I know from where Wikipedia has taken it?
Right. So in Wikipedia itself, let me share my screen. I stopped sharing. Is it? Sorry about that. I'll just share one particular tab of special.
I think you're muted.
Yeah, I think it's that screen share thing that's sort of muting me. I'll just share my entire screen. Can you just see my screen? All right. So on the special relativity page, there's this section called origins and significance, right? Now, whenever someone says special relativity, the first thing that comes to our head is this particular famous 1-inch equation, E equals mc squared, 1 inch, half inch, I don't know. Right? E equals mc squared is the most famous thing. Now, where did this Wikipedia page get it from? Now, I can say that I read this from Wikipedia, but your question was, where does Wikipedia get it from? Now, you see, if I'm just reading this particular line combined with other laws of physics, the two postulates of special relativity predict the equivalence of mass and energy, blah, 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 as expressed in the mass energy equivalence formula, E equals mc squared, where c is the speed of light in vacuum. And at the end here, you see there's two citations right here, 6 and 7. That's where Wikipedia got it from.
Okay.
So those are what you need to be citing, right? So if I just hover over 6, it says Relativity, Special and General Theory. That's a book by Einstein. And this particular statement was taken from page number 48 of that book. That's what it says. Right? And then 7 again is from a book by Richard Feynman, 6 Not So Easy Pieces, from the 68th page of the 1995 reprint edition. Right? So that's what you need to be citing, not the Wikipedia page saying in this origins and significance section of the special relativity page of Wikipedia, there's a formula called E equals mc squared. That's wrong. But what you would be citing is in Einstein's book on special and general relativity, in this particular page, he talks about the mass energy equivalence. Does that clear it out?
Yes, it does.
Awesome. Right. This brings me to a very good point. All of you, I'm sure, are familiar with arXiv, right? This thing, arXiv.org. Now, if you've attended yesterday's talk, you would have realized what you can and cannot pick from all of this. But I'll just quickly tell you what it's all about. I've been taking a lot of time. I'm really sorry about that. Now, arXiv is a preprint server, which means anytime you write a document, you can always put it up on arXiv so that others know what you're working on. And the chances of copying it is much lesser. I wouldn't say zero, but it's much, much lesser than if you didn't put it up on arXiv, right? And the advantage is everyone uses arXiv quite a lot. So it's guaranteed that your work will not go unnoticed, right? So people from all around the world can have a look at your paper who are working in a very similar field as yours. And that's exactly what we call peer review. Right? Peers as in you and I check each other's papers and make sure we don't have a clash of topics as much as possible. But if it's unavoidable, then we can collaborate and produce the same paper as two independent papers, and whatever it is, if it's a effect or if it's a phenomena or something, then it'll be named after both of us, something like that, right? Now in arXiv, there are, vaguely speaking, there are two types of documents that you can find. Ones that are published in some or the other journal that is worldwide used, and some that are not published. So you have published ones and you have not published ones. Now, at this particular stage where you're working on a review paper or a very simple project as you are right now, you are free to cite any of those, right? Like for example, if I'm choosing a paper from arXiv that is not actually published in any journal, like for example, I don't know, I pick up some high energy physics theoretical paper, but I noticed that it's not actually published in a journal related to high energy physics. It's fine at this stage, right? You can still use that paper saying this particular person wrote this paper, has a preprint. You don't have to specify that, but it's implied, right? When you cite this arXiv paper that is not published, it's sort of implied saying this particular person has already worked on it, and so I'm giving the credits of this particular part, this particular section, to that person, right? You don't have to really tell that person directly, but it's implied. All of that is implied. So you have to, at this stage you can cite, but as you go higher and higher into your research careers and more papers you write, it's always a good idea to try to cite or refer to those papers that are published. The reason being, published papers are always peer reviewed, right? Which means several people have seen that paper and have approved of it, right? And you know, it's sort of saying that I checked this, he checked this, the entire world checked this, and it's correct. And that's why it's okay to publish this. So when you're referring to published papers, all of that is implied, right? The paper that you're referring to that is in a journal has already been verified by thousands of people. And so you're confident naturally, by default, if I may say, that particular paper is authentic, right? There's no problem in that. Whereas this thing at higher levels, when you're referring to preprints, there's always a possibility that stuff changes, right? Because they're not published, which means they're subject to change, right? So that's a slight thing that you'll have to take care of when you're going further in your research careers, when you're writing more and more papers. But at this stage, you are free to cite either the published ones or the unpublished ones. It's totally left up to you. But again, I reiterate this: no Wikipedia links, no YouTube links, no SciPop or Pop Science articles links. Okay, yeah, that's one thing that I suddenly remembered, and I thought I should let you know about it. I'll stop sharing and probably stop blabbering. Any further questions?
I have one question.
Yes, Shashwat, go ahead.
Yeah, well, you said we can't actually keep references to the Wikipedia links, but can we keep references of some other website links like say Fox.com or something else like that?
Yeah, see, that's the thing, right? I mean, those Fox.com and websites like those write articles for the general public.
Okay.
You are not the general public, right? You are writing a scientific paper. If you're writing a general public article, like a blog post or something like that, then yes, you can refer to all those things. But what you're doing here, this particular project of yours, is going to be a scientific article.
Okay, so for the reference, we have to check the published articles.
Exactly. So if your Fox.com article, for example, let's say is on differentiable manifolds, right? Some random topic off the top of my head. Now, what Fox.com does is it will try to explain the whole concept of differentiable manifolds.
Yeah.
Someone from a non-scientific background can also sort of get an idea as to what's happening.
Yeah.
Right? But as a science person, you must always look for a proper reference from where that article was written.
Okay.
Right. Let me just see if I can show you a quick example. Any further questions similar to this? I'm assuming you can see my screen. I'm going to go to this website that I refer for physics news. Right? It's called phys.org. And I'm just going to go to some random one. Right? Let's pick some Okay, let's pick this, right? Groundbreaking technique yields important new details on silicon, subatomic particles, blah, blah, blah. Right now, this, if you see this part,
Yeah.
this article, it doesn't contain any data, right? I mean, this is an experimental physics paper, topic, but you don't see any mathematics, you don't see a lot of things. But what you do see is something that is made for the general public to understand.
Yeah.
Right now you see this statement, right? In a regular crystal or silicon, there are many parallel sheets of atom. That's fairly simple for us to understand, right? Even if you're from a non-science background, it's easy for you to understand. But as a science person, what you should focus on is these kind of things, right? Publish online this particular DOI lattice in a journal called Lattice Dynamics, Fifth Forces, blah blah blah, whatever that is, right?
Okay.
So you should look for those. You should look for the actual journal published articles, because all these articles that you see on websites like these are based off of published stuff.
And we can actually access those articles through the references given by the website.
Exactly, right? Now, there are some cases where the articles are locked, right? I mean, you can't access the entire paper except the abstract of it. In those cases, and I should not be telling you this on record, but it's fine. You can use websites like Sci-Hub, which bypass those security measures and you get those papers unlocked.
Okay, what's the name of the website again?
So yeah, so it's called Sci-Hub. I'll just type it on Google, and this will be the symbol.
Thank you.
Now the URL keeps changing because apparently the scientific community thinks that open source stuff is illegal. Right? I mean, they still want to make money off of research papers, and Sci-Hub is completely opposite of that. It wants to make sure that all the research papers of any subject are accessible. Right? So what Sci-Hub does is it bypasses that security lock and it gives you access to that paper. Let me just see if I can give you a quick example. This particular theory called the Kaluza-Klein theory. I hope my screen is still shared and you can hear me.
Yeah, your screen is there.
Right, so I'll come down to the reference section and I'll probably pick this one. I don't know, one of these was locked, so I had to use Sci-Hub. I don't know which one that was. Is it this? Probably Klein's paper. And my net is quite slow, so sorry about that. Right, now you see, I think it was this paper. Yeah, now this particular thing, I cannot read the paper. I can only see the summary of it. This particular paper by Oscar Klein, I can't actually see it, right? I can only read the abstract of it, but that's not enough for me. I want to read the entire thing, right? And it says this is a subscription content, which means you're supposed to pay to read this article, right? Now what Sci-Hub does is it bypasses this, right? So if you want to use Sci-Hub, you have this DOI right here, right? So you just copy this DOI. And I'm going to go to the Sci-Hub website. Sci-Hub, oops, sorry. Right, and I'll go to this thing. Now here I'm going to enter the DOI code, the entire URL, and I say open. It gives me that paper. It gives me this particular paper. I mean, it doesn't matter, but you know, I have access to this paper now, right? Now, if you're using papers like this, you would still cite it in your document like this. Okay, you don't mention the fact that you use Sci-Hub to read that paper.
Of course, it's illegal, right?
It's a personal secret, right? It's a personal secret, and I'm telling this on a meeting with 30 people, 20 people.
Thank you.
Okay. You would still be quoting this particular paper as it is in Wikipedia here. As in, you know, it's a paper by Oscar Klein on this, and it has this name, published in this journal, this particular edition from the pages 895 to 906, and it has this particular DOI, right? You would still cite it like that, but you don't have to tell anyone that you used Sci-Hub to read that paper. That's your.
We're just gonna have to tell anyone that we paid for that.
Exactly, right? So that's your personal secret. People will think you paid for it. That's okay. Let them think that.
Yeah.
Okay.
Thank you.
Yeah, that's about it. And this is what Sagar was trying to tell you before, right? When I took a quick break. This is exactly what Sagar was telling you about Sci-Hub and stuff, right? So the process is quite simple, right? You just have to go to the main page of Sci-Hub, put your URL for the DOI, and you just say open, and it opens it up for you. Right?
Sir, does it work for books also?
Sorry, I didn't catch that.
Does it work for books?
I think it does. I've never really tried it. But in case you do need some books, I can suggest you some websites, right? I'll just put it up on the chat box here.
Okay, sir.
That one and that one and that one. Anytime that I have required books, I found them in any of these websites, right? So it's always worked out for me. But if in case you do not, I think it should work for books as well, right? I'm not entirely sure, but yeah, perhaps you can just experiment it out and let me know if it works for books as well. If it does, then great. Otherwise, some workaround must be found for that. All right. Any other questions?
I have a question.
Yep, go ahead.
Could you specify once again what exactly goes inside citation and what exactly comes under the reference part? Because it's quite confusing.
Right. So about that, I think we'll get back to that when we're actually learning how to cite papers in LaTeX. Right. So we'll have a session on citations and bibliography. I think it's best dealt with in that session. Right. I mean, you can already get an idea as to what it's going to be like with these things. Right. So you have the author's name first, and then you have the name of the book or the paper, and then you just say which journal, which edition, which page numbers, stuff like that. But we will deal with it in detail when we are learning how to cite, when we're learning to do bibliography in LaTeX. That will be, I think, the session on Tuesday, I think, Sagar, or Monday, I don't know.
Even I don't know, but I just want to look.
So wherever that session is, we will deal with that in detail over there. But otherwise, you can stick to the format, the syntax that is seen in Wikipedia, right? Because it's fairly official enough.
Actually, that's not my doubt. I wanted to ask if you have a particular website or something, how do you
Okay.
differentiate if it goes to a if it goes to a citation paragraph or it goes to under reference or something?
Right. That again, we'll deal with that. We'll deal with the differences between citations and references and all of that when we're dealing with citations and bibliography in LaTeX. I think it's best dealt with there so that you have a continuity of topics right there. Because if I tell it now and then 2 days, 3 days later, if you have a session, you're not going to remember much of it. So I think it's best left for that. Right. But in brief, if I was to tell you, research papers are your citations. So the thing is, citations are what you do in between your text, right? So you have a statement, and then you put a number next to it. That's your citation, and that citation corresponds to a particular reference, and that reference is going to be a paper. Right. So I'll just quickly show you the special relativity thing. This particular statement, this number 6 and 7 is a citation. The 6 and 7 are called citations. What exactly is at 6? This is your reference, and that's why you see it under references. And that's like the very brief introduction to citations and references. And then there are also something called primary sources and all of that, but we'll deal with it when we have the session on bibliography in LaTeX. I hope that's okay. I hope you don't mind with that.
Yeah, okay.
Right, thank you. Any other questions that I can address? Right then, seems like there's nothing else. Thank you for your patience. I know it's a weekend night, and you guys have been here for so long. And great job on the projects and everything. I was listening to the discussions with Sitara, and yeah, so super excited to see all of you working on them. And if there's anything that we can help you out with, please do reach out to us. I personally can help with astrophysics, set theory, theoretical physics, particle physics, quantum mechanics, and those things. And Sagar also is approximately the same topics. He's a little better with dark matter and stuff because he's written papers on that before. Whereas I am more towards QFT, quantum field theories, and particle physics, and those kind of topics. But yeah, if anything at all that you require, please do reach out to us, and I will see you whenever the next session is. Thank you very much for your patience. Have a good evening and night.